All right, so here we are now on 6.2 on the simplex method. So we're going to look at the maximization with problem constraints in the form less than or equal to. All right, so this is going to be our first problem, and we're supposed to use Slack variables to write the initial system for each linear programming problem, then write the simplex tableau, circle the first pivot, and identify the entering and exiting variables, and then use the simplex method to solve the problem. So this is a problem solve. The maximize p equals 3x1 plus 2x2, subject to 5x1 plus 2x2 less than or equal to 20, and 3x1 plus 2x2 less than or equal to 16. So both of them are less than or equal to, so those are the constraints we're looking at. And then we're subject to also the x1 and x2 have to be greater than or equal to 0. All right, so what we need to do first is we need to rewrite this. And so we'll write this as, if I can find my pen here, where'd it go? There it is. All right, so we'll add a slack variable to the first one, so that'd be 5x1 plus 2x2 plus s1 is equal to 20. And then we have 3x1 plus 2x2 plus s2 equals 16. And now we have to solve this for 0 with p on the left side. So it's going to be a minus 3x1 minus 2x2 plus p equals 0. And then our x1 and x2 have to be greater than equal to 0 still. Okay, so that's going to be kind of our initial system that we're going to work on. And now we're going to start by writing our initial simplex tableau here. So first things first, we write, our x1, x2, and then we have s1, s2, then we have a p, and then we put a line after that. And then we have our slack variables we put to the left, S1, S2, and then over here we'll put kind of a dotted line, and we can continue that line a little bit more. And this is going to be also our P. And now we can write basically the constants from these equations over here into this function. Now the key thing is we can't rearrange the rows. We can't just say, okay, this is S2, this is S1, and move things around. We have to do it in order as it is. So S1, so that means we're looking at this first row. So that's a 5x1, a 2x2, a 1s1, a 0, and then a 0 for P, and then it equals 20. So this is our equal side over here. Then we have a 3, a 2, now it's a 0, and now 1, and a 0, and a 16. And now we have a negative 3, a negative 2, a 0, a 0, a 1, and a 0. So this is our initial tableau. And now what we have to do is we basically are just going to solve it. So we're going to basically do what it says here, circle the first pivot, identify the entering and exit variables and all that stuff. But we're just going to go through as we would look at this in an actual problem. So first things first, we find the largest negative. So it's that. So this is the column we're going to be dealing with. And so now we're going to look at the quotients because that's going to be how we find which one is the circled variable. And so we're going to take our 20 divided by 5, which is 4. We're just taking this value divided by this. Now we'll take 16 divided by 3. That's 5 and a third. And we want the smallest. So that's the smallest. Therefore, that is going to be our pivot point. Okay, so this is going to say that this is going to enter and this one is going to exit. Okay, so that's kind of what they're asking here, which ones are entering and which ones exiting variables. So we're entering the x1s, exiting the s1s, and so now when we write the next time we do this and we actually do calculations, this is going to be our row that is going to be x1. All right, so now what we need to do is we need to make this a 1, and then we're going to make those zeros. So before we go too far, we're just going to say, well, let's take 1/5 row 1 and replace it into the row 1, okay? And so we're not really exiting yet. All we've done is just took a variable. So this is still S1, S2, P, and so this is, and maybe to save space, I'll just keep this as x1. So this is now 1, and that's going to be what, 2/5. That's going to be 1/5. That's going to be 0. That's 0 divided by 5. That's going to give us a 4. And we can go ahead and put that there still. And so this is still 3, 2, 0, 1, 0, 16, and minus 3, minus 2, 0, 0, 1, 0. Now, the next time we do this, this is going to be our pivot, and we're going to actually switch those out. And so what we need to do is to make the everything else in that to be 0. So we're going to take a minus 3, row 1, plus row 2, and that's going to be our new row 2. So this is kind of how, matrices work. And so we're kind of back to doing matrix operations, but with a tableau. And then we're also going to take 3 times row 1 plus row 3, and that's going to be our new row 3. All right. So when we do that, that's going to be negative 3 times that plus that is going to be 0. That's going to be a negative 6/5 plus 2. And we're just going to work our way down. And I have to go to the next page because I'm out of space on this one. And so let's go ahead and write our x1, x2, s1, s2, p. And now remember the x1 row came in. So we have now x1 and we have s2 and we still have p. Now the first row was still staying the same because that was our one. Then we had what, a 2/5, then we had a 1/5, and then we had a 0 and a 0, and we had a 4. And we took a minus 3 times that row plus this row. And when we do that, we get a 0. Then we get a 4/5, and we get a minus 3/5. We got a 1, and we got a 0, and we add those together, we get a 4. And then we took 3 times that row plus that row, so that gave us a 0. That gave us a minus 4/5. That gave us a positive 3/5. That gave us a 0 and a 1, and then we add that in and we get 12. Okay. All right, so that's kind of really our first step operation. And so now what we do is we're looking at the bottom part, and we're looking from here all the way over to here, and we're looking for any negatives. And we want this largest negative, so that's this one. So that means this one is going to be entering, and now we have to find the exiting one by doing our quotients. And so our quotients is going to be, in this case, 4 divided by, and it's going to be 2/5. So multiplied by the reciprocal, that's 20 divided by 2, which is 10. And here we're going to take 4 divided by, now we have 4/5. So multiply by 5 is 20 divided by 4 is equal to 5. That's the smallest. So that means this is going to be our pivot point. And so that means here, this is going to exit. Okay. Now, we can do, several things. We can say, okay, well, let's take and make this a 1, and that would make it so we could do that. But maybe we could do two things at once, or even let's do two things at once. Let's make this one a 1 here. So that's going to be multiply that 5/4 row 2 is row 2. But because we want this to be a 0, I notice that's 4/5 minus 4/5. So if I take row 2 plus row 3 and make that the new row 3, that automatically goes to 0, and then I don't have to worry about other fractions. Now, when I do this, I'll get a 1 here, and then I'm going to have to multiply by a negative 2/5 of that row and add it to that one eventually, but I'm not too worried about that. That's pretty easy. So, doing that, we're going to have now, we're going to already start exiting and entering here. So that's x1, that's x2, that's a p. We're going to keep our top row the same for now. 2/5, 1/5, 0, 0, 4. We're going to make that a 0. Multiply by 5/4, we get 1. Multiply by 5/4, we get what? A negative 3/4. And that's going to be a 5/4. And that's going to be a 0. And then that's going to be just a 5. Okay. And this one is going to be, we're just adding those two. So that's a 0, and that's going to be a 0, and that's going to be a 0, and that's going to be a 1, that's going to be a 1, and that's going to be 16. And so we still need a pivot here. We need to make that a 0. But again, the reason I did this was because I saw that that was easy just to add together and I didn't have to multiply, then add again. So now what I'm going to do is take a negative 2/5 row 2 plus row 1 and make that my new row 1. All right, so let's go ahead and say that's x1, and then we have this is x2, and then this is a p. See if we can get all this in here. So it's a 0, a 0, a 0, a 1, and a 16. That's a 0, a 1, a negative 3/4, a 5/4, a 0, and a 5. Now, 0 times that, so that's still going to be a 1. Minus that plus that, that's going to give me a 0. Minus 2, so that's going to be minus 3 plus that. That should give me a half. And then minus that and that, so those cancel. That's going to be minus a half. And that cancels, so that's 0. Those cancel, so that's a minus 2, so that gives me a 2. And I think that's all. So now I look and I go back to that bottom row of the P's, and I only go up to the S2 row column. Those are all positive. So now we stop and we say, okay, well, x1 and x2 are going to be my variables. So I'm going to say let the other two, which is s1 and s2, s1 and s2 equals 0. So x1 is equal to what? Well, x1 is equal to 2. X2 is equal to, now we come over here, that's equal to 5 because this is x1. If those are zeros, then this x1 is 2, x2 is 5, and my max p is equal to this value right here, 16. Okay, and so that would be kind of my solution. S1 and S2 are 0, x1 is 2, x2 is 5, and the max p is 16. All right, so that's how I'd work one of these problems that are kind of in a simpler form. We only have, x1 and x2 and s1 and s2. Some of them will get more complex, but we'll run into that when we get to there. So let's stop there and come back for some more.